everyone, so today we'll be doing chemistry numerical based on your NCERT exercise only from the chapter Some Basic Concepts of Chemistry. So our question is to calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. So basically, here we need to find the amount of carbon dioxide when 1 mole of carbon is burned. So we need to write a reaction which is C plus O2 gives us CO2. Carbon plus oxygen gives us carbon dioxide. So here we know the molar masses of all the three. So the carbon's molar mass is 12 gram per mole. Oxygen, it's basically 16, but it's twice. So we'll write 32 gram per mole. And for carbon dioxide, it's 12 plus 32, which is 44 gram per mole. Now in the first subpart, we need to find the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt. Now here we can see that 1 mole of carbon produces 12 gram mass of carbon. So since we have 1 mole of CO2 as well, therefore answer will remain the same, which is 44 gram of CO2 will be produced if 1 mole of carbon is burnt. Now, our next subpart is saying that 1 mole of carbon is burnt in 16 gram of dioxygen. Now, here we can clearly see that it's 16 gram of dioxygen means it's half of oxygen because the total mass of oxygen is given as 32, but here it's showing as 16, which is half of it. So we'll write the reaction again and we'll check it out. Here carbon is present as 1 mole, therefore it will be 12 gram only, but oxygen is half of it, which is 16 gram. Therefore, here oxygen is basically the limiting reagent. Now we'll see the concept of limiting reagent, which is basically the element which is present in least amount. Here O2 is present in least amount. Why? Because it's half moles. Now how we'll see this? We'll see this by a formula which is number of moles by stoichiometric coefficients. We'll check the limiting reagent by this formula, number of moles by stoichiometric coefficient. So basically in oxygen, the number of moles is half and stoichiometric coefficient is given as 1. So basically the limiting reagent will be oxygen only as it has half of the moles. Now to find the amount of carbon dioxide, we'll use the formula number of moles is equal to given mass upon molar mass. So basically the number of moles of oxygen is given as half of the moles. So firstly, we'll write the molar mass, which is 44, the total mass of carbon dioxide. And after calculating the given mass, we'll getting it as half into 44, which will be your 22 gram of carbon dioxide. So this will be our answer. Now, our third subpart says 2 moles of carbon are burnt in 16 gram of dioxygen. Now we'll again write the formula C plus O2 gives us CO2, but this time we have 2 moles of carbon and 16 gram of oxygen, which is basically again half of the moles. But this time we'll again check the limiting reagent since it's clear that 2 moles and half moles. So basically O2 has lesser amount of moles. Therefore, O2 will be the limiting reagent. Now we know the formula for limiting reagent, which is moles upon stoichiometric coefficients. So we know the moles of carbon, which is 2, and its stoichiometric coefficient will be 1 only, therefore it has 2 moles. But our oxygen will be half in amount. because its number of moles is half and its stoichiometric coefficient is 1. Therefore, here our O2 is the limiting reagent. Now we'll be again using the formula for number of moles, which is equal to given mass upon molar mass. Now, since O2 is the limiting reagent, so we'll do the reaction according to the limiting reagent. So, we'll write the number of moles of O2 only because it's the limiting reagent. So, reaction will be occurring as per its requirements. So, again we'll write the same. Half equals given mass upon 44 gram, which is the total mass of carbon dioxide. So, it will be coming out to be 22 gram of carbon dioxide as the answer for this question. So this is it for the video. Do like, share and subscribe. Thank you for watching. Bye bye.